Hey guys, my name's Seth and welcome. We are going to do a little coding right in front of you, and while I'm coding I'm going to try and talk to you and explain why I am coding this particular game. So if I stop, it's because I'm trying to think of what's going on. But anyway, so we have great students for Simply Coding that are learning how to code in JavaScript and other languages too. We do all sorts of languages. But one of our students sent us a game, and we asked them, we want kids to send us games and say, this is a game I really like, and I'd love to know how it was coded, how it was created. And so one of the games they sent us was called Threes, T-H-R-E-E-S, exclamation point at the end. And I played the game. It's one that you've probably seen. You have a grid, and you have all these numbers, and you're shifting the numbers, and when two of them match, like two sixes collide, it makes 12. Now, I'm not going to rebuild that game. It would take me a lot longer than this video can hold. But I do really like the idea that you have all these tiles out there, and when they collide, how do you know what to do? And that brings in a great lesson about arrays. And so I do want to talk about arrays. Now, some of the stuff you see, this SJS, we have a library that we're using, and it's just a bunch of JavaScript functions to make things a little bit easier, putting an image on the screen, doing some of these simple things of resizing it. But for the most part, especially when we get into arrays, this is going to be pure JavaScript. So let's get us a player. So the player, I'm going to use the one block, and it looks like it's a JPEG, and that player needs a type. This is from our library. This is how we do collision detection, and it's a simple concept. And then we also need to move him. I want to move him to the far right of the screen, so that's going to be 800 and 0. And before I do that, I want to set his size. I want everything to be on a grid of 100. So you can see the height of our game is 400, and our player is going to be 100. Oh, I can't move him yet. And so there will be 4 rows of 100. I reached out to touch the screen, but you guys can't see that. Okay, so next, let's get the player moving. So the easiest way to have him move is to do a window dot event listener. There's a word I'm missing. Add. The word add. Add event listener. Spelling is very important. Okay, there we go. And then we're going to make a function. So what we're saying is we want our window, our browser, to listen for an event. And that event is going to be a key down event. And if that key down event, I'm going to make this a little bit larger, so hopefully, nice, it fits all on one screen. Okay, so if that key down event has a key code equal to key down, which is a variable inside of our library, the down key, and that down key has some number and it's in our library, so I'll never have to remember it. So if that happens, then I want you to move our player to player.x to whatever x location he is. But in the Y direction, I want you to add 100. Okay, so that should get the player moving down. Let me save and refresh, make sure I did it right. And I did not, of course. So while I'm coding this and talking to you, there's going to be some mistakes. Key down is not defined. It is right. It is called the down key. So I'll try and minimize those mistakes. And he moves down perfectly now. Okay, let's get him moving up. Anytime you can copy and paste in coding, do it. All right, so here we go. And so now we just need to change this to when it's the up key, and we want to minus 100 so that he moves up and he stays on that grid. So let me save, refresh, he goes down, he goes up. We got Superman there. Okay, next, now let's go ahead and build in a number. So let's go ahead and build in, let's do this. Let's do a set interval function, and set interval functions run on a timer, and they're going to run code every interval. And I'm going to say run it every 1200 seconds, I guess. 1200 milliseconds. And then let's create our first block. So let's make our blocks sjs.image. And I just realized we have not made the array. So I need to make an array. So if you look over here, we have all these images. And I'm going to create an array. I'm just going to name it array. And this array is going to be equal to every one of these images, starting with the 2 block. We don't need the 1. And is it block singular? Yes. And we're going to comma. So the way that arrays work is an array is like a variable, but it can have multiple values. So each one of these images is given an index number, and that index number is going to be associated with its spot in the actual array. So to show what I'm talking about, if I go ahead and I add an alert right here, and I say show me array position 3, what that's going to do is it starts with position 0. Here is 0, 1, 2, 3. So we would expect for it to alert us this 12 block. Okay, so if I go ahead and save and hit refresh, images 12 block. So that's the way arrays work. Each one of these is given a number, and it's associated with that. It's accessed by square brackets and then the name of the array, which I named array. We could have named it anything we wanted, basically. So what I'm going to do is we're going to create a random number, and that random number is going to be, we're going to generate a random number, and it will be between 0 and however many blocks we have, and then that's the image that will get displayed. So if I come down here and do math.floor so that we don't go above the amount that we have in the array and get nothing, times math, let's see, and then we have to generate the random number, and we're going to times it by array.length. Length is one of those hard words to spell. Okay, so if I go ahead and hit, and now we want our image to be array, and then rather putting in a number, we're going to put in random, because that will generate a number for us. Now what's going to happen is every little over a second, a new block's going to show up, and it will cycle through. And so this way, oh, a 2 did it a couple times. We make sure we're getting a new block every time. Now we're going to add some properties. Now that we see that that's working, we want the size to be 100 by 100. We need there to be no friction so that it will just move seamlessly. We need for to push this block to the right. Now these are properties from the function in our SJS library. So let's go ahead and refresh now, and we should see blocks coming at us. Boom, boom. Oh, we need to do that a little bit more often, huh? Oh, we got a blank one. I didn't know we could get a, maybe I have a bad square in there somewhere. Yeah, let's make it more often. There we go. I like that. I wonder what block that is. Did I type one of them in wrong? 12, 24, 48. 96, oh yeah, 192. I put 196. You guys were probably yelling at me, and I couldn't even hear you because it's a video. Okay, so now that that is working, let's go ahead and move it to the right place. Blocks.move to. Now we want to move it to 0x, and we want to make this y location be random, but not times array.length. We want to times it by, so we want it to either show up on 100, 200, 300, or 400 in our y direction. Well, really 0, 100, 200, or 300, and the block's height will cover the rest of that row. So if we do that random, it should now show up. Let's make sure it can show up on every location. It hasn't shown up at the bottom because I have to do 4. I don't know what I was thinking. 4, let me save, refresh. Now we'll get a random, and look at this. Now we have all of these numbers waiting to collide with us and decide what happens. Now we don't want them to get stuck on that right side. So let's do a quick on hit. And this on hit is going to be between blocks, which needs a type. Blocks.type. So on hits compare types, and they will create an event. So we want blocks, if it hits the right screen, which is defined in our library, then we're going to create a function. X will represent the blocks, Y will represent the right screen. And when that happens, I like everything on one line when I'm showing this. We want the X to get destroyed, which X is representing blocks, and Y is going to represent the right screen inside of this function. So now if I hit save and refresh, these blocks will hit the right screen. They should just disappear. Nope, they didn't. The reason why is because they are bound by the wall. So we need to do no bounds equals true. And we have to spell true correctly. There we go. Now they're going to disappear when they hit the right side. So now we need to think about, okay, so we are this 1 block, and when the way the game works is 1 hits 2 and becomes a 3, and then you have to hit your same block. So when we hit that 2 block, we want to grow into a 3. So we're going to have to keep track of some numbers. Hopefully I don't lose you here. But we're going to say our player as a block 1 is number 0. Okay, and then our block, here's what I'm going to do. I am going to cheat the system a little bit. And I'm going to make a 2 block come out very beginning. We want array 0 to come out. And we want to give him a number of 0. And we're just going to make sure that we do this little collision detection. So basically we're going to have a block at 0, and we're going to have a player at 0, and we want them to collide using an on hit. So let me do this on hit. Here we have our player versus the blocks, and it's going to make a function x comma y, and that function is going to make, so okay, so if x.num is equals y.num, then we want we want to make the image go to array y.num plus 1. We want to destroy that block, and then we want to update us. Since we hit a like block and we moved up 1, we need our x.num to, this is how I always do it for some reason, to equal itself plus 1. Okay, that should be good. Let's see what happens here. We're going to get a 2 block out very first, and boom, now we're a 3. Now we haven't made collision detections with any of these other blocks yet. And even if I saw 3, I don't think we added that property to, man, there hasn't been a 3 this whole time. It's not going to work anyway. So what we need to do is we need to give all of these blocks a property of none, and we want to set that property equal to whichever random number was generated, because that random number is also their position in the array. So if I hit refresh, I'm going to hit this 2. We made the 2 come out every time. Now we do have to wait for a 3. So come on, 3, where are you? I know you're in there. Okay, half this video is going to be waiting for a block to come out. Boom, 3 is 6. 6 goes to 12. Show me a 12. 12. And then we're going to go to 48 if we hit a 24. Now, this game's super easy because I could sit right here and just wait for a block to come. And if I hit these other blocks, nothing happens. Oh, I just can't resist. And now we'll go to nothing because the array keeps going. So we won the game. But let's make it a little bit more challenging. So we have the condition of if the blocks are the same. Well, what if I hit a block that I'm greater than, let's just leave it at greater than, not equal to. We already have equal to handled. Okay, so if I'm greater than that block, so I'm a 24 and I hit a 6, what should we have happen? Well, let's have us go to that number. So if you're at 48 and you hit a 2, you're going to go down to 2. And that would make, let's always destroy that block, and then that will make so that x.num is equal to y.num, so that we can keep track of who we are. Let's test that out first, and then we're going to build what happens if we are less. Okay, so if I go to 2, and then I go to 3, I can't remember what we did. Do I need to hit a bigger one? No, I got to hit a smaller one. Bigger ones still don't do anything. So we need something smaller than a 6. So if I go 12, I think I'm doing really good, and I hit a 3, now I'm a 3. All right, so let's make it now. If you are a larger block, so let's say x.num is greater than y.num. No, I just did that. Okay, So if we are less than x.num, then let's have us go down 1. So how would you do that? So we want to take our array number and minus it by 1. Our image and minus it by 1. Now let's go y.destroy, and then let's go x.num. We need to minus ourselves, equals x.num minus 1. All right, so now let's save and refresh, and watch this. So I'm going to hit a 2, and if I hit something bigger, I'm going to go back to a 2. So now you have to avoid every block except for the one that you are. So that's the game. Hopefully those arrays made sense. What we were trying to do, sorry, I can't stop playing for some reason. I need to quit. I just don't want to see him die. He'll die. So what we were trying to do is, here is the array with every block in the game. And we are trying to use our player's number property, which we just made up. And this is raw JavaScript. And keep track of which block we are. And also keep track of the block's number property so that we know which block it is. And then we're able to run these if statements and make decisions and make the blocks collide, and then you grow and shrink. Okay, hopefully you guys enjoyed that. I'm going to put that on our website in our code dungeon, where there's tons of games you can play, tons of kids' games that they've made, and you'll be able to look at this code. You can edit it, put it in an editor, mess around with it. I'll put all the images and everything so that you can download it. Let us know if there's games that you play that you'd like to understand certain concepts, how they work. We'll try and recreate that portion, make a fun little game out of it, and have some fun. Thanks, guys. Bye.